Now I want to discuss with you one problem which is related to the topic continuity, where the continuity will be tested. Function is given, the point is given where the continuity is required to check. Problem is for you, check the continuity of function f(x) is equals to mod x upon x. The value of function is mod x upon x if x is not 0, and the value of the function is 1 if x is 0, and check its continuity at x equals to 0, that is at origin. To check its continuity at origin, simply we need to calculate left hand limit, we need to calculate right hand limit, we need to obtain the value of the function at the testing point. If all three comes equal, we will say it is continuous, otherwise it is discontinuous. So to obtain the left hand limit, we will follow the proper procedure. That procedure is, at x is equals to 0, we will find left hand limit at x is equals to 0 will be given by limit x tending to 0 negative fx. Now an important fact to remember to all of you, here x tending to 0 means and negative I am writing to obtain the left limit, meaning by we will take that part of function where x is not 0, it is less than 0, x negative. Here the function is given in two parts. One part, when x is 0 it is 1, when it is not 0 it is mod x upon x. So ultimately x may be more than 0 or may be less than 0 will be considered in the first part of function. So we will write here limit x tending to 0 negative, function fx will be taken as mod x upon x. Reason, x is not 0, it is less than 0, 0 negative. So we write it like this, limit h tending to 0, in place of x we will write that point minus h where the continuity required to test, that is mod of 0 minus h upon mod of h. Mod of 0 minus h is what? Mod of h. And this is ordinary, we can write x, it is 0 minus h. Mod of h upon minus h, this become h upon minus h under the condition limit h tending to 0, this result become minus 1. We say the value of the left hand limit of the function is minus 1, and if we go to calculate its RHL, that is the right hand limit, the procedure is limit x tending to same point 0, but we will write positive because we are obtaining the right hand limit fx. Now we need to check whether which part of the function is required to take, because x is not 0, it is more than 0, either it is less than 0 or more than 0, function is mod x upon x. So we will say this will be limit x tending to 0 positive mod x upon x. As per the condition, we will write limit x tending to 0 will reduce to limit h tending to 0, and this mod x will be replaced by 0 plus h, and this x will be replaced by 0 plus h, which gives us limit h tending to 0 mod h upon h, that is what? 1. So we will say the answer is 1. So right hand limit is 1, left hand limit is minus 1, and f of 0, that is the value of function at x equal to 0 is 1 as per equation number 3. So what you are observing here, I have told you to calculate left limit which is coming minus 1. I have explained you how to obtain the right hand limit, that is plus 1, and the value of the function at 0 is given 1. These three values are not equal. If it is not, we say the function is discontinuous. So clearly we will say left hand limit is not equal to right hand limit. So, function is clearly discontinuous. So, this is a uniform pattern to obtain, to check the continuity or discontinuity of the function. Here you can observe that right hand limit is 1 and value of function is 1. That's why it is continuous from right side but discontinuous from the left side. If left and values are equal, it is continuous from left side and discontinuous from the right side. If all are same, it is continuous from both sides, or we say function is continuous.